Hello and welcome to Easy as Pie with Mr. Carpenter. I am Mr. Carpenter, and today we're going to look at the third and final method of factoring for Algebra 1 and the third of four possible factoring methods for Algebra 2, and that is, of course, the infamous trinomial. Now, when I say trinomials, I'm talking about a very specific trinomial, a trinomial for which you cannot do greatest common factor. Right? So in this case, something like 3x cubed plus 6x squared plus 9x. Yes, this is a trinomial, but this is not what I'm talking about because it has a greatest common factor, right? So the trinomial that doesn't have a greatest common factor and usually is a quadratic. So something along the lines of x squared plus 5x plus 6 would be a trinomial that we'd be looking to factor. Right? And the goal, right, the end result for this factor is going to look something like this. It's going to be two sets of parentheses. The first slots are going to be filled in with x's. And the second slots are what we're going to be looking to fill by using the second and third numbers. So as we know, we can identify these by their a, b, and c values. And the goal is to find factors of c that add up to b, or in other words, factors of the last number or the last constant that add up to the second number or the second coefficient. So in the case of this problem, I'm going to make a little factor, not really a factor tree, but more of a factor table, right? So my c value is 6. So the goal is to find two numbers that multiply out to 6 and add up to 5. For example, 6 times 1 is indeed 6, but 6 plus 1 is 7, and I need that to be a 5, so that would not be the correct set of factors. Well, 3 times 2 is 6, and yet 3 plus 2 is also 5. So because these two factors multiply out to 6 and add up to 5, they are going to be what goes in the remaining spots in my factoring. So I have a positive 3 and a positive 2. And if you were going to go out and multiply this polynomial, again, you will notice that it will reset back to what it originally was, right? We combine those like terms, and we're back to right where we started. So this is going to be our strategy moving on for pretty much any trinomial that cannot be factored by a greatest common factor. I can't stress that enough. I see people doing this strategy with trinomials that already have a greatest common factor. You have to do that greatest common factor first, and then maybe what's inside your factor parentheses might be able to use this method for. So let's look at a different one. We'll erase this, keep that little tidbit in blue. And how about, and I'm just making these up on the fly, minus 10x minus 24. Okay, now in this case, my b value is negative 10. Do not forget about the negative signs. And my c value is negative 24. Okay, so my c value is negative 24. So I need factors of negative 24 that add up to negative 12. I'm going to fill in these spots as well. And since I have to since the two numbers have to multiply to a negative number, what that means is one of them has to be positive and one of them has to be negative. So I can kind of fill in that spot as well, right? Because there's no way that they'll both be negative or they'll both be positive. So factors of negative 24. Well, how about 8 and negative 3? 8 times negative 3 is 24, negative 24, but 8 plus negative 3 is 5, so it's not that. Okay, well, what about its opposite? Negative 8 and positive 3. Well, that is going to add up to negative 5. So it's none of those. How about 12 and negative 2? Well, 12 plus negative 2 is 10, but I want negative 10. That's another common mistake people will do. They'll find the factors that add up to maybe positive 10, but I really want negative 10. So it's not those. But if I flip them, right, negative 12 and positive 2 still multiplies to negative 24, but then I add those together, and that gives me my p-value. So that means that those are the numbers that I'm looking for, right? So x minus 12 and x plus 2. And that would be that factored form right there. Okay, let's do one more example. And these are, of course, basic trinomials where the a value, right, so this x squared, there's no coefficient before it, so it's not like 3x squared. So this video is just me covering the basic trinomials. I'll probably make another one covering more advanced trinomials for Algebra 2, but I find that in general, being able to factor just regular trinomials gives you a lot more mileage than you might think. So I think they deserve a video of their own. But one more. X squared minus 3x. Actually minus 11x plus. These are tough. How about 10? There we go. So in this case, my b value is negative 11. My c value is positive 10. So the goal is to find factors of 10 that add up to negative 11. And because the c value is positive, I know that it's either going to be two positive numbers or two negative numbers, right? Because two negatives will also multiply out to a positive. How do I know which is which? Well, I have to add up to a negative number, right? So if I have to add up to a negative number, I can't have two positive factors because they're never going to add up to a negative number. So this is going to be two negative factors here. So x minus and x minus. So what two negative factors could I work with? Well, negative 5 and negative 2 will make positive 10, but those will add up to negative 7. Here's one that people don't really think about all that often. Negative 10 and negative 1 are indeed factors, because negative 10 times negative 1 is positive 10. And you add them up and you get negative 11, which matches what I need over here. So now I've found my two factors, x minus 10 and x minus 1. And with that, I think I've covered most of the scenarios you might find in a factoring trinomials. So I will cut it here, but thank you very much for watching, and I will see you in the next one.